la trying to get youth to learn how to debate with really fun games using these mediums. Jumping right into it, AR and arguably mixed reality is part of a continuum, in my opinion. AR, mixed reality, allows you to blend the real world with a digital artifact or virtual world so that they talk to each other, they understand each other. When you do this right, you create experiences that can't be duplicated in any other medium or anywhere else, frankly. As I said, it's part of a continuum, and I include virtual reality as part of that continuum. I include the AR cloud as part of that continuum, and I'm going to explain why. Augmented reality allows you to overlay digital artifacts, providing context to the real world, people, places, or things. However, it doesn't break the rules of our reality. It provides information, additional information that we see when we browse the internet or access information. Mixed reality, by contrast, does that, but breaks the rules of reality. It's allowed to do things that you only see in a movie or you only see in your dreams. In this little animated GIF I have going on here, this is a video attributed to Magically, one of the startups in this space, creating devices in this space. And you have children wearing these devices, theoretically, I think they're children, in this auditorium or gym. There's a whale sort of crashing through. The actual beginning of the onboarding process for Magically sort of allows you to experience a whale either floating in your space or outside your window. It's fantastic. It breaks the rules of our reality. On the other side of that continuum is virtual reality, where now you've totally broken every rule of your reality because you're no longer in your reality, you're immersed in a different world. So whereas virtual reality takes you to a different place, augmented reality brings a different place into your space. I strongly believe, this is the opinionated Noble coming in, I strongly believe that if augmented reality allows you to provide context to things and people and places that you traditionally only see in a 2D world or on your computer, and if mixed reality allows you to blend the real things with digital artifacts in a way that they understand each other, then, and when virtual reality allows you to totally immerse yourself in a space, then the spatial cloud or Magicverse or what some Microsoft calls, the AR cloud, gains a new use case for VR, for virtual reality, where you can now traverse the digital artifacts that you're able to sort of interact with AR, or play with in VR, or work with in mixed reality. So spatial cloud essentially becomes that warehouse or that layer on top of our real world that allows us to tap into these digital artifacts in a way that you can actually work with. It's basically both a storage mechanism and a way to sort of interact, or always go to a place where things are always going to be anchored, regardless of whether you're using a phone, a device, or some other kind of input mechanism. Going into the how track, I'm going to make some assumptions that you wanted to go down this path because you, one, are curious, hopefully. Two, that you have the use case for your app already, and I'm glad to talk to you about it after this talk. You have basic understanding of what a game engine like Unity 3D is. You've maybe set up an Android environment before, not required, but useful in order for you to sort of build to either iOS or Android. You need to have some understanding. Not difficult at all. So we'll jump right into what makes this medium work, or how we can avoid working through OpenGL and doing all the hard math in order to make augmented reality work. Different libraries and APIs and SDKs are available to us. Apple has something called ARKit. Euphoria has different platforms. They're the OGs in this space. Google has something called ARCore, which evolved from something called Tango. And what ARCore does is gives us the tooling and the toolkits to do a couple things that I'm about to talk about here, the core fundamentals of AR. The first is environmental understanding. Being able to, with the lens of your phone or device through a computer vision mechanism like a camera, being able to scan your planes available, vertical or horizontal or diagonal, your space, to understand what is occluding, what is occupying the space, in order for you to do more with it, like walk around a digital artifact in space, or in your space. And that is motion tracking, being able to sort of persist a cube, for example, that is 3D rendered into anchor it to a specific spot or thing or person, like a Snapchat filter, and not being able to lose that persistence as you move around. The next feature you get for free with ARCore is light estimation. And very recently at Google I/O, they added for more realism with your space. Really quick, as if we were in the space with a lot more sunlight, naturally the sun will cast shadows. The challenge is if you bring a digital artifact into that space, it should also cast shadows to provide some sense of realism as you walk around it, try to track around it or interact with it. And light estimation, again, comes for free with it. HDR, environmental HDR, makes it a whole lot more real. The next feature you get for free, one that I'm very excited about, is something called Google is calling cloud anchors. Just basically multiplayer or multi-experiences. Now, if I'm able to keep that cube over here, you should be able to pull out your device and also sort of see what's happening, what I'm seeing, without having to huddle over my phone. Seeing things from your perspective, I think, is the power of real, like true spatial computing experiences. There are tons of real-world examples. We're doing the how track, but I wanted to sprinkle some of these things in. Getting into a lot of computer vision, machine learning, if folks have ever played around with TensorFlow or TensorFlow.js, you can actually do a lot of things with helping people identify things, people who are either low or no vision, low or no mobility, or even games enhanced by blending the physical with the digital in order to provide more context, or to break the rules of reality, do fun things. With cloud anchors, I touched upon that. There are a couple of fundamental elements that you have to, and I'm not going to go through every single one of these. You essentially want to be able to encourage users to move. So a good use case of cloud anchors are games. And so being able to sort of play 3D chess, or it could be anything, by allowing your players to interact with one single or multiple pieces of content from their perspective, allow them to move and take advantage of the elements in AR. I'll make these slides available for everyone. So all in all, there are a couple features of the ARCore functionality that we're going to go over, that we've just overviewed briefly. One I'm going to double tap into is augmented images. And augmented images allows you, again, to anchor, take a marker, being a physical object, and then have that be your anchor for a digital artifact. And it can be moving. I can sort of hold a playing card and sort of generate my wizard on top of that playing card on there, and, you know, so on and so forth. Demo time. I do have a problem with demo time. I lost my laptop 2 days ago, and so I don't have a demo. I do have this presentation recorded, so we're going to fall back to it. Again, as a product manager, just because you can doesn't mean you should. I say that quite a bit. So why build an AR experience for a site like Carfax? Now, Carfax, unbeknownst to me until I started looking for a great demo, sells cars. I thought they were just a car records company, but they actually sell used cars. I love this car because it has doors that go like this. It's an IA. My problem, if I could afford it, would be, since it's a used car and Carfax doesn't have a dealership, I'm just going to have to trust that the money I'm about to shell out is going to go to, I just trust that the car is going to look exactly like what it looks in the 2D picture. And I can like swipe through these pictures and see what it's like. But I'm missing something that I get at a dealership, the good part of the dealership, not the nagging salesperson trying to get you into the closet. I miss that sense of presence with that vehicle, walking around the vehicle. I've never been in an IA. What does it feel like to go into the IA? Yeah, sure, I have these pictures. They don't really do me any good. So what I did was tackle that problem space by trying to solve for that specific use case. And this is what that looks like. I just buried the lead. So here I'm scanning, I just scanned that image. And I get to walk around the car. This was a rush demo at my last talk, so I didn't get to walk around the car. It's animated, so the lights blink. I'm able to manipulate the vehicle, as in like blow it up and sit it right next to me so I can actually walk into the car. I can actually just get that sense of presence, that embodied presence. This demo is actually why I lead with that opinionated comment that augmented reality versus mixed reality versus virtual reality are all one and the same. It's all part of a continuum. Because if I'm in the vehicle, I'm in virtual reality, technically, right? If I'm outside the vehicle and the vehicle is in my space, I'm outside that experience. So essentially, I took myself into a digital environment, which is inside of the car, and I stepped out. So I traversed virtual and augmented reality and mixed reality somewhere. I didn't really break the rules because the car didn't do anything. It didn't fall off the table or anything like that. All right, so how do we make this work? Well, first you need a phone that is compatible. Now, if you choose to build with ARKit, Apple's analog to ARCore, you're tied to Apple devices only, compatible Apple devices only, I should say. If you use Android Studio and Sceneform, you are unfortunately tied just to Android devices, compatible Android devices only. So I choose to use Unity, or I choose to build to web versions of AR and XR, but that's outside of the scope of this conversation. For this conversation, we're going to talk about building to Unity, because with Unity, I can basically choose my build target and bring in my CocoaPods or whatever. I'm not an iOS person at all. I'm not even a developer. But you can basically bring in the libraries that you need or the packages that you need to build to your iPhone. Or you can do the same for Android, or you can do both. In order for ARCore, since we're going to do Android, we need the ARCore SDK, a compatible version. It's they're at 1.93 now, but anything greater than 1.6 should get you what you want. So where do we want to go next? I'll choose for you. So, how does augmented images actually work? Well, one, we need a 2D representation of a physical object. We need to be able to take that photo or that image and teach a computer to understand it. This is done by pre-compiling that image or a set of up to 1,000 rather, images with the Unity package that ARCore provides. And once that is pre-compiled, and it's added to a database and it's given a score. A score anywhere from, and I'll get into that, I'm getting ahead of myself. Next, you want to be able to sort of detect those images. So, one, I've taken a photo or an image that I took of a physical object, perhaps many versions of that picture, so that in different lighting conditions, if I really want to be thorough. And I pre-compiled, put it into Unity, or if I'm using Android Studio, classified it through the mechanism available to you there. Next, I need to do something with the device. So on my phone, I need to be able to sort of detect it. So using something called a raycast from my camera, being able to sort of scan my environment, remember environmental understanding, being the first thing, being able to sort of understand that, yes, I have a picture and I'm looking for a hit in my space. So detecting the images is very important for this to work. And then now that you've detected that image, render that asset. A 3D asset or some sort of digital representation. I've seen scanning a photo of the sports page of a newspaper, that medium, and sort of overlaying a video of that, a clip of that horrible goal the Warriors lost. I don't watch sports ball. I shouldn't have made that joke. But apparently Toronto won yesterday. Get to that next. Tiny question. The question was, sorry.
Yeah, well, this question, I don't understand the image and the
Wait. Perfect question. Because I get into that. So yeah, so the question is, all right, now I've got an image, right, that I've pre-compiled into a database. I've got a physical object, or where that image came from, like the real world object. Like, how do both of those talk to each other? So once that image is classified and identified, it's given a score. Let me sort of show you. So based on and I'll get into like the type of images that work, the type of images that don't. Each image that you take a picture of gets a quality score, okay? And so a higher quality score, something greater than 70% or 70%, allows the ARCore engine to better detect and get a hit and do something, allow you to do something with that image. I'll get into that here in a second. So yeah, the first part is being able to ingest the photo or multiple versions of that photo into your database. And to do that, you essentially are just, in Unity, you're essentially just dragging those images that you've classified into your, I normally just use an images folder within my project hierarchy. If you've ever used Unity, you probably have your own way of organizing your assets. But yeah, just basically point to that. And then next, you create an image database, the image database itself. And Google calls it an augmented reality image database, and it actually has basically a session that is listening for, it's basically iterating for every single image in that database and seeing whether you can then get a hit. So now, how do you get a hit? So this is actually how you combine the digital with the art. So we've been dealing with the digital. So in your space, let's say I want to detect this water bottle. I've taken a picture of this water bottle, dragged it into my image database. On my, in my game controller, in my AR controller, I'm basically saying, whenever the camera scans my plane or scans my environment, find anything that hits this contrast, it hits this image just by contrast. It can be black and white, it can be a black and white image, but as long as the feature points of this gets a hit, and maps back to your image and any of the images in your database, do something with it. In your game controller or your AR controller, if it's not a game, what you're doing is giving it location points to anchor to. You do that within Unity, and with Unity, you notice that within the hierarchy, you can actually, the game object itself, or the object that you're interacting with, you can actually give it X, Y, or Z space, dimensions, or basically by meter, like where you want it to be in space. So whenever I see this, I can say 0 meters, 0 by 0 by 0 would be like overlaid directly over this. If I say 0 being height, the next 0 being, you know, left or right, or maybe left, I would just say put this right on top of it by putting this at 10 meters above the image, or perhaps put it to the side of it. That video that you saw earlier had, and I don't have Unity on this computer, I apologize, better to show the tell. But the dimensions are essentially, not the dimensions, but the positioning for that digital artifact is set up so that I can place it to the right of wherever I got the scan. So it's not on top of my the card was not on top of my computer, but to the right of it. The version that you saw was right on top of the computer, but then I can also move it to that. So that's good. Come again? There is a physical location. This can move, but once this is your marker, right? So once I get a hit, ARCore is anchoring, ready to anchor your digital artifact to this hit. Now it's up to you to tell it where to anchor it to by that positioning, right? And it will respect that based on the motion tracking features that you get in ARCore that I talked before if you walk around that physical object. And it won't move unless you need it to move. Let's say you're doing a little game where a car moves around this space, right? So I scan a picture of my playing card, and I want a dragon to animate out of that card. I need an initial anchor point, okay? And I can change the positioning based on X, Y, or Z axis based on the editor's positioning. That is my choice. But then animate that dragon to fly around my space. That takes advantage of other ARCore features that says, all right, whenever you hit a bounds, just loop around and come back.
So that anchor point can also be like, I'm like, a stalker, like a stormtrooper in the picture. We don't want to set that anchor point.
Yes, you can define that. And to define that, you're doing a couple things. For every, so this is the update, and in Unity, the update method is updating every frame, sub-seconds, right? So every single time, once your camera is open with your app, there's a ray cast, so basically an invisible laser, if you would, that is just scanning your environment and just creating a mesh around to understand your environment. Once you do that, you've obviously, you've obviously told it to look for a physical object in your space to get it hit. So that ray path, that invisible laser, is just scanning around the space. And you can use some UI elements like what I used in mine. You notice a little rectangular bounds. I can show you the video again. I actually have the demo on my phone, but unfortunately this is not my machine, so I can't show it. So after this talk, you can definitely experience it. But we just put these sort of visual cues for your end user in order to know that something needs to happen. So look, point your camera within the bounds of this box. And I call that a fit to scan overlay. So essentially right now, what I'm doing is for every image in my database, I'm basically looking for a hit, right? And I'm trying to anchor the digital artifact that I created to that physical object once I get a hit. I'll just stay on that for a second. Okay. With that, you can do some pretty cool stuff. This is a demo that someone at Google did with Google Play Music. You're at a record store and you don't want to patronize or give them money, so you would. Terrible idea. So you would basically take out your phone, scan a record, and you'd be basically able to play that. If you're a Google subscriber, you get the music for free. If you're not a Google Music subscriber, you get to pay for it, and the record store gets no money. So now you see how you can basically render those assets. Google, as of Google I/O this year, enhanced those functionalities. Before, it was very hard to track, to basically anchor on a moving target. It's a lot of math that you have to do in order to sort of keep that tracking and avoid drift while you're doing so. And so definitely check out Google their code labs, codelabs.developers.google.com for how to use ARCore 1.9.0 in order to achieve some of these advances in marker-based AR, which is augmented images, what they're branding. A couple notes about rendering. So, you need a couple utilities. That card that you saw, I did not create myself. I wish I was that good. I essentially bought it from one of these stores. You can also do it for free. I've created a lot of assets myself as well, but I'm not as good as the detail that you got with that card. There are new formats coming along. The traditional ones are OBJ files. Apple has some pretty, I can't remember what they call it. GLTF is my bag. You can sort of use a GLTF file. We won't go into what a GLTF file is, but it's essentially the format. You're building for mobile, by the way, so you want to be as efficient as possible to be more responsive and increase performance with your AR experience. You don't want, after 5 minutes, to overheat your phone. And a lot of these 3D, you can optimize a lot of these 3D assets to meet the needs. Using a format like FDX or GLTF allows you to do less work in order to further optimize for mobile. And this is a specific, and even worse if you're using a Head 1 wearable, you have to be very conscious of performance. So in summary, the anatomy of your app becomes an ARCore device that you need. A sense of realism using the light estimation features. You're scanning your environment in order to understand it. That's the plane detection. The ray pass being an invisible laser thing that I was talking about for your camera in order to get a hit. I added some UX pieces to this. If you're doing something with your plane, with your environment, it's advisable to sort of use a plane visualizer. Now that demo, mine happened so fast I didn't really need to overlay a plane visualizer. I just got a hit. It was like a 90% success rate in my image database. So the second I pulled out the phone and scanned that car, it just popped up. So I didn't really need to do anything. But traditionally, you want to have that as a fallback in case there's some issues or you didn't render. That image wasn't GLTF file and sort of compressed and still retain its quality. You need a system controller. Unity folks in the room probably know it as a game controller, but you know, basically, you have to be able to sort of add your logic in any way. You have an event system in order to sort of handle interaction. In the case of the car app, you know, if I didn't want it on the table and I wanted it more wall space, I can actually do a pinch and zoom and move it and actually walk it into the car. You need a TV canvas, that's your initial picture that you have, obviously interactions, and then some magic, because I actually haven't scrutinized every single line of code in the ARCore code base. General pro tips, don't use a bitmap, a BMP, I don't think that's a thing. Make it high quality. Detection points are of high contrast, so as I was explaining earlier, you can actually take a black and white version of whatever photo you have and it'll still work. It's just looking for contrast areas in order to sort of do what it needs to do. You need to have the image the right dimensions, large enough for it to be consistent, for it to consistently work. Don't use plaid. I mean, well, you can, but it won't work too well. And this is actually obsolete now. It says don't try to track moving objects. That was from, I'm a recovering startup founder that tried to do a lot of AR and fitness and sports. And so we try to just anchor player names and health information as the players were moving around at James Madison University. That didn't work too well, so we ran out of money. But Google solved that problem. There's normally a breakpoint here. We can talk about design principles, and I think actually we'll just jump right into that. How are we doing on time? 7 minutes. I'm gonna actually leave some time for questions. So I'm actually gonna, more questions. I'm actually gonna sort of leave it here. I will make these slides available to you. In case you have any need to sort of just get more information. Question? Yep. I don't know. So that is one of the magic things that I was talking about. So the question was, how is the quality score calculated? Now, knowing Google, if I were to pause it, they have a couple ways to do that. So Google Cloud provides an image classifier library as well. There's some APIs available in TensorFlow that you can take advantage of. Essentially what it's doing is it's trying to detect as many feature points on that 2D representation of what you took as clearly as possible in order to discern if light changes, that it can actually do something with it. But I actually don't know the technical bits as to how that happens.
So what happens if you're facing your TensorFlow 3D object, but then you go out of frame? How does the phone know that the object, the AR object is in the same location?
Yeah. So remember I said, especially if it's not moving, or even if it's moving. Once I'm able to scan this, I basically registered this against that image database. I've gotten a hit, right? Now it's up to me based on what I want to do with that hit. So now if I anchor my object to position it either overlaid or near it or on top of it, it should, by design, respect that, right? So whether I move out of frame or not, I basically have an anchor, and this is where cloud anchors comes in a little bit. But I'm cheating, essentially, basically saying, if I go out of frame and I come back, I'm still getting that hit. The camera's still seeing what it is. So just persist that. But that won't move. You'll notice some experiences with AR start getting a lot of drift. So it was here, I moved out of frame, I came back, and it's just sort of drifting and trying to find it, and the visual artifact just drifts right back to the object. That's a hard problem to solve. I certainly don't know how that could totally be solved. But essentially, once you lose that connection, It just needs to make it back up, and it's a performance thing. How quickly can you recalculate based on, you're basically doing it again. Remember that update, and that update function is essentially scanning every single frame, so just in sub-seconds. So like the second I moved out of frame and then went back, that update function iterates again, whatever it's doing, and whatever your code says to do is doing it all over again.
So going to that demo that the Google record store,
Yep.
how difficult would it be in terms of kind of reversing what you had for the car and recognizing, like, using TensorFlow to train for like which cars make your model and trim and being able to recognize it and like doing some.
What's the question?
Basically, recognizing the training to recognize a car like in reality and doing augmented.
Right.
Similar to that.
That's essentially what we did.
Gotcha.
But I see what you're saying. I see what you're saying. So what you would actually do is it's just like you would with TensorFlow, right? You need to train your model to recognize cars, right? And to train your model and to recognize cars, you use images, 2D representations of it. So your image database doesn't have to be the same image. It just has to be an initial, I wouldn't advise using Unity for this, by the way. But you'd essentially just train your TensorFlow models on, or Keras, or whatever you're using to understand what type of car you're looking to identify, or what car you're looking to identify. So when you pull out your phone, you're looking in the parking lot, maybe you're just recognizing every car as identifying as a car, but maybe you're looking for your car, then you can anchor something over your car, right? And so that's essentially how you do it. So it's very, very possible. Actually, they're very compelling demos by before. We got one more minute, so.
How much of this is actually on the device? Are you running your app to recognize the voice on the device, or are you
Yeah, in this iteration, I'm actually sending it to the front. Actually, that's not how I did this app. It depends on what you want to do.
How is it different from I don't know if it rotates, but I asked Cheetah, got Google.
Right, so all the heavy lifting. So in this example, you probably wouldn't do too much on the edge. You would actually do a lot of the calculations.
If I can get it to work out.
I think this example was simple enough that I actually still
like this and doing something like this, like video, visual, talking, like
So I worked with ARCore last summer, and
so we're doing up
one of the issues that, so basically my project was getting a designing a floor plan based on what the camera sees from my phone. And one of the real issues I kept running into was that the plane visualizer seemed to upwards as I moved further away from the thing that was generating. It was almost as if it was rising. Is that a problem with ARCore, or is that a problem with Unity and 3D?
That may be even a problem with all the above, including your phone or the device too, because what they're doing is it's trying to feign depth sensing as well. So if it thinks it understands your scene, your environment, and it really doesn't, they're going to be artifacts like that. There's so many quirky. I think I talked about one of the quirky. Somebody asked about essentially what amounts to this is drift issues. That would have happened with your situation even worse, right? Because if it scanned your planes and it really didn't understand it, it's basically going to think that your floor is at an incline and the representative. So I don't have a real good answer for you. I just know that Google, Apple, others are iterating on this. One last thing I want to mention is to definitely check out Unity's solution to the silos that some of these companies sort of put up. It's called AR Foundation. You can actually sort of, I have a code lab on that. Either launching next week on one of these. It's going to be on Twitter, but definitely if you want to learn about how to do that. Not saying it's going to solve that specific problem, but you definitely take advantage of like the latest and greatest from Apple and Google in one solution. Apple's really doing some impressive work as far as their tracking.